This is slide number 16 and I am your presenter Asloob Mudassar. Referring to the figure in the previous diagram, we can say that when a spherical wavefronts are generated from the point source, then for the curved part of the wavefronts, K and R, that is the propagation vector and the position vector at that point, both change from point to point such that the angle is 0 between them, and we can write that K dot R is equal to KR. So we can write down the spherical wave traveling to the right as A over R e to the power iota KR minus omega t. So A over R is the amplitude, that is the amplitude will fall off as 1 over R, and this A is the amplitude at the amplitude of the point source. So A over R is the amplitude at a distance R from the point source, and the phase factor is e to the power iota KR minus omega t. So in order to write down the profile of this wave, we can set t is equal to 0 in it, and we have spherical wave of profile is equal to A over R e to the power iota KR. And you know that we shall be using all the time the profiles of the waves, that is the profile of the plane wave or the profile of the spherical waves in the optical system when we want to investigate the optical system using Fourier tools, and the traveling waves are not required over there. Now the cylindrical waves. The use of cylindrical waves is generally very limited in the field of optics, and particularly in Fourier optics, but for completeness a brief review is given. Cylindrical wavefronts can be generated when plane wavefronts are made to pass through a long but narrow and thin transparent slit made on a dielectric material or piece of metal with the rest of the part completely opaque. And the sentences or the statements are more accurately depicted in the diagram. So this is in the diagram you can see that the plane waves, wavefronts which are infinite in extent, but we have shown only small segments of that one, are incident on an aperture. The aperture is clear in the center in the form of a narrow long slit, and the rest of the aperture area is opaque, that is the wavefronts cannot pass through them. And when these plane waves passes through the slit, due to the diffraction, the cylindrical waves are produced, and on the other side of the aperture you can see these cylindrical waves propagating along the z direction. These cylindrical waves are also infinite in extent, but we have shown the small portion of the plane wavefronts, the small portion of the aperture with the slit in it, and a small portion of the cylindrical waves propagating towards the right. And now this is the end of slide number 16.